guys, David here in ISR4 with the 2630 Thunderbolts. Today we'll talk about the amazing robot that have an arm that can do L1, L2, L3, even L4. They're very fast climb and even more softer on behind the bumpers.
Okay, so we'll start with the arm and gearbox. We have a gearbox with 2 Kraken X60 motors for each pivot of the arm. They have a ratio of 1 to 85.5. So we built a gearbox to be as tough as possible. We have thick plates, 10 millimeter and 8 millimeter. We built the chassis like that as well. We'll get to the arm. We have 3 millimeter carbon fiber. We have 3D printed pivot points that are strengthened with carbon fiber. We have a HED14 pulley up here, and thrust needle bearings that are closed here with this lock nut.
Sure, so we'll move on to our end effector. So a cool thing about our end effector is after our pivot point here, which is just herringbone gears 3D printed from polycarb, we have an angle, and that allows us to reach L4 and L1 without having another joint at the end. So you, because you're at an angle and you already need this pivot to intake and score, and you don't need another one to reach the geometry for L4 and L1. Our gripper itself is built from 4 millimeter carbon fiber plates and just normal 3-inch compliant wheels. Onto our climb. So our climb is very simple. We just lock onto one of the bars of the cage and go up. A cool thing about our climb is that we decided not to use a ratchet. The problem with the ratchet is you're going to have problems if you opened the climb accidentally and need to close it, or all sorts of things. Then that can cause issues. So we decided to use a shaft collar here that tightens onto the dead axle and is connected to the climb. And that just adds friction. So it doesn't completely stop our descent, but it slows it down significantly. So we're in the air for at least 10 seconds.
Moving on to software, we use a feed-forward control together with motion magic on our arm to get smooth and good motion. Using the feed-forward, we can make the arm stay wherever we want and without applying the feed-forward from force. And then we create trajectories from different points, so our arm will go from different points we want to scoring without hitting anything on the way. We use the profile PID to get ourselves into the place in the reef. Our driver has 2 buttons to choose which branch he wants to align to in the reef, and then he can choose which one by the closest face. Together we have 2 cameras, AutoCam cameras, running photon vision on orange by 5s, and that gives us full localization, and the cameras see the Apple tag on the reef face whenever we're close, so we detect them all the time when we want to place. We can intake coral and our arm goes. Basically, we have a high stall position, so our opening will be faster.
Thank you so much, 2630 Thunderbolts. I wish you the best of luck in the rest of the season, the rest of the event, and see you soon.